All right, now there's one more topic I want to talk about just to clean things up a little bit. If you go on to Gen Chem 2, you're going to talk about this a lot more. I just want to clarify this because we kind of talked about this back in chapter 4. Now I want to clarify this a little bit more. So the last topic I want to talk about is what happens when we add a solvent or a solute to a solvent. So there's actually a heat change that's going on. So we describe this, or we can measure this, as something called the heat of solution or the enthalpy of solution. This is the amount of heat that's generated or absorbed when a certain amount of solute is dissolved in a certain amount of solvent. So this is actually a two-step process. So let's say we're adding sodium chloride to water, okay? And so in the first step, what happens is that we take that sodium chloride crystals and we split them up, and it becomes gaseous sodium ions and chloride ions. So we take that crystal, which is a solid, and we heat it up to the point where that crystal basically disintegrates, breaks apart, gives up those crystals. And so this process where we take a solid crystal and make it become gaseous ions, this is actually called lattice energy. This is the energy that's completely required to completely separate 1 mole of a solid ionic compound into gaseous ions. Okay, this is something that we're actually going to talk quite a bit more about in chapter 9 and chapter 10. So when we look at ionic bond formation, this is something that we're going to talk about a little bit more. Once that happens, once we break up those ions, break up the compound into ions, then we can actually hydrate that. So remember that the ions go into the solution, and then the water molecules around rearrange themselves into, based on the charges and the positive and negative charges of the water. So we measure that as the heat of hydration. This is the enthalpy change associated with the hydration process. The water molecules arranging themselves around the ions. And so we can derive an equation for this. And this one's pretty straightforward. The enthalpy of the solution is equal to U, which is this lattice energy thing, plus the heat of hydration. So the change in enthalpy of hydration. Okay, and again, U, this is the lattice energy. Okay, so if we were to look at this graphically, what this all means, let's take a look at this picture. In the first step, you've got sodium and chloride. They're in a solid. So this is a salt crystal. Okay. In the first step, you heat up this crystal to the point where now the crystal structure is gone and you just have ions. And so this is called lattice energy, and it took 788 kilojoules per 1 mole of sodium chloride to do that, to vaporize from the liquid to the gas state. Okay, so now you're in the gas state. Okay, we take those ions in the gas state and we surround them with water molecules, and we rearrange those water molecules so that way the positive ions are attracted by the partially negatively charged oxygens. The negatively charged chlorines are surrounded by the partially positively charged hydrogens. And so this is the process of hydration that we talked about back in chapter 4. And so for the heat of hydration, this actually is a negative 784 kilojoules per mole. So to get to the heat of solution, we take that positive 788 and add a negative 784 to it. So the overall process to go from crystal by itself, where all the ions are hydrated, this actually just costs us a positive 4 kilojoules per mole. So when we make a solution, there is an energy change going on, and these crystals break up. There is an energy change going on. Okay, so that's the whole point I got on this one. I just want to talk about this in terms of enthalpies a little bit more.